All right, let's jump right in. We're about to explore one of the most powerful and complex weather systems on the entire planet, the Indian climate. It really is a story of incredible extremes, of predictable, ancient rhythms, and of these immense natural forces that shape the lives of well over a billion people. I mean, think about it for a second. It seems kind of impossible, right? You've got scorching deserts, icy Himalayan peaks, and then some of the absolute rainiest places you can find on Earth, all inside one country's borders. So, how does that even work? That's the big question we're going to unpack right now. We're going to break it down into 5 parts. First up, we'll look at the engine that drives this whole thing. Then we'll follow the seasons, from the chill of winter to the crazy heat of summer. We'll get to the main event, the Great Indian Monsoon, then watch its slow retreat. And finally, we'll take a look at what the future might hold for this amazing system. Okay, so let's get into that engine. To really get a grip on India's climate, you first have to understand the 3 geographic giants that basically call all the shots. You can almost think of them as the main characters in this whole drama. So first, you've got the mighty Himalayas up north. They act like this colossal wall, shielding the whole subcontinent from those freezing winds sweeping down from Central Asia. Honestly, without them, a huge chunk of India would be way, way colder. Second, you have the vast Indian Ocean. That's the fuel tank, you know? It provides all the moisture that feeds the monsoon, and it helps keep temperatures from going too crazy along the coast. And third, it's just plain old geography. The Tropic of Cancer slices right through the middle of the country, which splits it into a tropical south and a subtropical north. These 3 forces are always interacting, setting the stage for everything that follows. So now let's see how these forces actually create the seasons. We're going to start our journey through the year in the cool, dry winter and watch how it slowly gives way to the intense, baking heat of the Indian summer. Now, check this out. This map does a fantastic job of showing you the 2 different Indias that exist during winter. See these lines? They're called isotherms, and they just connect places with the same temperature. Up north, you can see temperatures dropping down to 10 or 15 degrees Celsius. But just follow those lines south, and you see a much, much warmer peninsula, just comfortably hanging out between 20 and 25 degrees. So why the big difference? Well, it all goes back to our key drivers. The north gets what's called a continental climate. Since it's far from the ocean, it cools down really fast. On top of that, snowfall in the Himalayas sends these waves of cold air down into the plains. But the south? It's surrounded by the ocean, which acts like a giant thermostat, preventing any real sharp cold season from ever taking hold. But as the sun shifts northward, this whole pattern reverses, and it does so with a vengeance. The land, especially out in the northwest, starts to heat up like an oven. I mean, we're talking temperatures that can hit a blistering 48 degrees Celsius. That's 118 Fahrenheit. This insane heat does something really important. It creates this massive zone of low atmospheric pressure over the land. It's like a giant thermal vacuum cleaner just got switched on, and it's getting ready to pull in the main event of the year. Right, so that intense low pressure over the hot land becomes this irresistible magnet for all the cool, heavy, moisture-packed air that's just been sitting over the Indian Ocean. And this huge difference in pressure is what finally unleashes the most famous weather phenomenon in the world. Now, let's be super clear about what we mean by monsoon. Most people hear the word and just think rain. But that's only part of the story. A monsoon is technically a seasonal reversal of the wind. In the winter, winds blow from the cool land out to the warmer sea. But in summer, that pattern just dramatically flips on its head. The winds reverse, blowing from the sea towards the superheated land. And yeah, they happen to bring a whole lot of rain with them. And here, you can see that engine in action. You have all this warm, rising air over the ocean getting sucked in towards that low-pressure spot over the land. This powerful flow of air from the southwest, that is the Great Southwest Monsoon. It is the absolute lifeblood of agriculture for the entire subcontinent. So the monsoon doesn't just arrive as one single wall of water. It's more strategic than that. It advances in 2 distinct branches, like a pincer movement. The Arabian Sea branch smashes into the Western Ghats mountain range, and it just dumps enormous amounts of rain on India's west coast. At the same time, the Bay of Bengal branch moves up, but it gets deflected by the Arakan Hills over in Myanmar. And this deflection is key. It pushes a huge part of the monsoon northwest, straight into West Bengal and right up the plains of the Ganges River. But, what goes up must come down.
After a few months of relentless rain, the engine that powers the monsoon starts to slow down and the entire system gets ready to reverse course. This is what's known as the retreating monsoon.
And this withdrawal is a really gradual, orderly process. It doesn't just pack up and leave overnight. It starts way out in the northwest, in Rajasthan, in early September. By the end of that month, it's left most of northern India. Then the center of that low-pressure system shifts south, finally leaving the peninsula completely by the middle of December. The science behind the retreat is pretty simple. It's basically the arrival story, just playing in reverse. As the sun's direct rays move south of the equator, the Indian landmass starts to cool down. That powerful low-pressure system gets weaker and weaker. High pressure builds back up over the cooler land, and the winds start to blow back out towards the ocean. The great cycle is complete. And that brings us to the end of our climatic year. We've seen how this incredibly powerful annual cycle works like an engine for the entire subcontinent. But now we have to ask the big question: what does the future hold for such a finely tuned system? You know, this quote from our source material really just nails it. The monsoon is the great unifying force. It's a single system that affects the whole subcontinent. But the result of that unity is incredible diversity. You get the Western Ghats getting absolutely drenched, while other areas barely see a drop. The timing and the intensity of the rain create this huge patchwork of different climates, all driven by this one single annual rhythm. But this entire system is now facing some unprecedented pressure. Global climate models are projecting that the Earth's average surface temperature could rise by another 2 degrees Celsius by the year 2100. For a place like India, that's not just a number. A warmer atmosphere can hold more moisture, which could supercharge the monsoon and lead to more and more extreme weather events. And at the same time, one of our key climate drivers, the Indian Ocean, is also changing. Sea levels are projected to rise by nearly half a meter. For a country with a 7,500-kilometer coastline, that dramatically increases the risk of flooding, threatening coastal communities that have built their entire lives around these climate patterns for centuries. And that leaves us with the final, crucial question. The monsoon isn't just a weather pattern, it's the foundation of an entire economy, a culture, a way of life. So, as the fundamental conditions of our planet change, how is this powerful, life-giving, and sometimes destructive system going to respond? That really remains one of the most critical questions of our time.